Hello and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring prime factorization. Let's start with an example. Example 1. Each of the following is a prime number. Write each number as the product of two whole numbers in as many ways possible. Then write the factors of the prime number. So in problem A, we have the number 2, and we want to write 2 as a product of two whole numbers in as many ways as possible. So I can think of 1 times 2, that would give me 2, and I can't think of any other factors of 2. So our factors of 2 are just 1 and 2. Okay, to write 3 as a product of two whole numbers, I would have 1 times 3, and that's it. So the factors of 3 are 1 and 3. Whoops, why did I write 1 and 1? I meant to write 1 and 3. 5, to write it as a product, I would just say 1 times 5. So the factors of 5 are 1 and 5. To write 7 as a product, 1 times 7. So the factors of 7 are 1 and 7. So in terms of factoring, what do you notice about prime numbers? So I would say the only factors of a prime number are 1 and the number itself. All right, let's write a formal definition here. A prime number is a whole number that's greater than 1 that can only be divided evenly by 1 and itself. The number 1 is not prime because it only has one single factor. The number 2 is the smallest prime number and the only even prime numbers. So the first few prime numbers would be 2, 3, 5, 7, 11, 13, 17, and 19. Now, a composite number is a whole number that has factors other than 1 in itself. For example, 8 is a composite number because you can get 8 from 1 times 8 or 2 times 4. So it has factors other than 1 in itself. The number 1 is neither prime nor composite. Note, all even numbers except 2 are composite numbers. Excuse me. Example 2. The number 30 is written in its factored form 3 different ways. Identify any composite numbers and then factor them as the product of two prime numbers. So in our first example, we have 30 is factored into 2 times 15. So it asked us to identify the composite number in that expression. So the composite number is 15. So they want us to rewrite this as the 15 as the product of two numbers. So 30 equals 2 times 15 would also equal 2, and then 15 could be written as 3 times 5. 3 and 5 are composite numbers. All right. Now, if we write 30 as equal to 3 times 10, then our composite number now is the number 10. So we can rewrite 30 as 3, and then we'll rewrite 10 as 2 times 5. Okay, another way we could factor 30 is equal to 6 times 5. So this time our composite number is coming first, and that's the number 6. So if I want to write 6 as the product of two prime numbers, I would use 2 times 3 times 5. So what is true about all 3 prime factorizations of the number 30? And they all have factors of 2, 3, and 5. All right, prime factorization. To determine the prime factorization of a number, you must break down a number first into its factors, and then continue until all the factors are prime numbers. Prime factorization is written in exponential form. And I'll explain what that means more in just a minute. All right. So in example 3, tell what number is represented by each prime factorization. So in problem A, we have 2 squared times 3 times 11. So 2 squared would be 2 times 2 times 3 times 11. So this would be 4 times 33. And that would be 12, 132. So 2 squared times 3 times 11 would be 132. All right, in problem B, we have 2 cubed times 3 squared times 5. So 2 cubed would be 2 times 2 times 2. 3 squared would be 3 times 3 times 5. So 2 times 2 is 4. 4 times 2 is 8. So all of this is 8. 3 times 3 is 9. And then we have 5. So this would be 72 times 5. That'd be 10 and 3. So 360. All right. Now, in example 3, we started with the prime factorization. In example 4, we're going to start with a composite number, and we're going to break it down until it's rewritten as a product of prime numbers. Now, the way I do prime factorization is I use something called a factor tree. And if the number's even, I start with the number 2. If it's not even, then I try another prime number like 3 or 5. So let me write down the first few prime numbers. These are the numbers we can try to break the number down with. I usually try 2, 3, 5, 7. Every once in a while, you might need 11. So we'll just write the first few down. Hopefully we can work all of these with either 2, 3, 5, 7, or 11. All right, so let's start with 24. So I draw these 2 little branches. And for 24, if I divide it by 2, I get 12. So 24 is equivalent to 2 times 12. Now, this first branch with the 2, that's finished because that's a prime number. So now I'm going to do the same thing with 12. 12 is 2 times 6. So I have the branch with the 2 is finished, but I can now break 6 down to 2 times 3. Once you have prime numbers at the bottom of all your branches, you're done, okay? And so the prime factorization here, I have 3 2's. So that would be 2 cubed times 1 3. Now we can check our answer because we know 2 cubed is 8 and 8 times 3 is 24. So I'm going to box this number in here. All right. How about 39? Well, on the first problem, I started with 2 because 24 is even. But 39 is not even. So I can't use the number 2. So when I can't use 2, I try 3. Let's see. I'm going to try to break down 39 with a 3. So 39 divided by 3 would be 3 times 13. Ooh, I should have added a 13 up here because that's another prime number. Now, believe it or not, we're done with this problem because each branch now ends with a prime number. So here, the prime factorization of 39 is just 3 times 13. So once you get all prime numbers, you're done. All right. How about 60? Well, 60 is even, so again, I started with 2. 2 times 30. Then I break down the 30 with a 2. 2 times 15. Now, 15 is not even, so I can't use 2 this time, but I can use 3. 15 divided by 3 gives me 5. Now, what I'm noticing is I have prime number, prime number, prime number, prime number, all prime numbers. So, for the 2, I have 2 of them, so that's 2 squared, times 3, times 5. Now, we can check this because 2 squared is 4 times 3 times 5, which would be 12 times 5, which is 60. So our answer checks out. All right. All right. Now, pause the video and try the next problem on your own. When you're ready to check your answer, press play. All right, welcome back. For 110, I did 2 times 55. And then for 55, it's not even, so I couldn't use 2. 3 won't go into 55, so I tried 5. And 55 divided by 5 is 11. So my prime factorization is 2 times 5 times 11. All right, example 5. What number completes the prime factorization of 90? So they've already given us the first part, 2 times 3 squared times something. So I'm going to break down 90 here into 2 and 45. Now 45 is not even, but I know 5 will go into it. 5 times 9, and then 3 times 3. So I know my prime factorization is 2 times 3 squared times 5. So my missing number here was a 5. And that concludes today's lesson, prime factorization.